Alright, so let us play this new game. It's what the hell is this thing called? It's Exapunks. There you go, that's the name. That's the options menu, right? So it's like a cool programming type game. You hack stuff. I don't know. I mean, I'm a programmer in real life. It's kind of my job. So yeah, should be kind of fun. Also, I'm in a new room, so my setup is not so. I mean, I've set it back up obviously, but it's not perfect. Not how I would like it normally. So any like aim-intensive game and stuff, I don't really want to play right now. So this is good. I have a Axiom personal organizer. Okay, I have a meeting with Navas. Meeting with Navas Saturday 10/4/97. So it's 1997, I believe. 5:21 p.m. Find a source for bootleg medication. Alright, that's always good. Some bootleg medication. Usually a good sign. You have connected to Exapunks. Cast, Selenium Wolf, Deadlock. So I want to meet Navas. Well, Navas is not here. I guess this is a chat room. Yeah, chat subo. Play cutscene. Okay, there's cutscenes. Someone's at the door. I hate it. I can't even remember. Did I ask him to come up? Probably. Things have been hazy. I guess that's why he needs medicine. Every day more of my body is turned into junk. Okay, is your body, are you a cyborg? Oh, it's Navas. Hey.
Hey, can you hear me?
I can hear
I
you.
heard you were looking for some medicine for the phage.
I have the phage. It's like the plague. Hello?
Looks like you
You don't look-
definitely need it.
Yes, but you don't look like a cyborg. What the hell is the phage? That's right, Navas said they could find anything. Even bootleg medication. I mean,
So, I do have a source. I know where to get it.
alright.
It's cheaper than the real deal, but it's still gonna be pricey.
Great, of course. Navas pauses and looks me in the
The
eye.
going rate is 700 a dose. You need to take one dose every day.
700, what? $700? That sounds like an extreme high amount. And I need one dose a day to live? It's pretty bad.
Yeah, that's dollars.
Okay, it's dollars. $700 in 1997? Okay, yeah, you're screwed, buddy.
Sorry, I don't set the prices. I'm just a courier.
What is the real price then?
It's not like any of that money goes to me.
I'm sure some of it goes to you.
Anyway, if you do get the money, give me a call.
So you're just a mule. Hello, kinda dead here. ZZZ. Yep, that seems very very normal. Mutex, he's the only one active in Exapunks. Workhouse. Perform simple tasks to earn money at home. Disk 0 programs workhorse. Okay, well, I guess we can do some online work. Connected to workhouse. The heck is this? Kronos Capital Markets, job 0615. You will be shown images of receipts generated in the course of normal everyday businesses, and you will enter them digitally for bookkeeping and reimbursement purposes. I got a data entry job? Come on. Save a busy executive a minute or two. The only service that pays you for simple tasks you can do right from your computer. Easy work, easy money. Okay. So just stuff and price? Okay. Well, we see champagne. I hate spellings. CHAMPAGNE. Price is 140. It's expensive. DP Cabernet. Don't you have like systems which can do this? I guess it's 1997. Maybe they don't. DP Cabernet. Why did you buy two of them? 90. And why not just have an amount as well instead of having multiple entries? You know what I'm saying? Oyster PL. It's 35. I hope this is not the game. I know the game is about hacking because it starts like this. New York Strip. Dude, I hate my gaming keyboard. I can barely see the keys, the text here. Add truffles, which are expensive, right? Nope. Okay. Well, in this world, truffles are cheap. There you go. I can see it better now. Okay, I just set my keyboard to have a set one. Filet mignon. 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 Alright, it's $80. CHC 40. $12. And then special Order. 200. Verifying your work. 10 cents. Easy money.
Wow, a whole 10 cents.
Who are you, Ember? 0123. Okay, you're 2, I guess, of 0123. Emulated multi-branch emotional reasoning. Oh, it's an AI.
Congratulations.
Thank you.
You only need to do 6,999 more of these, and you'll have enough for today.
Yeah, that seems horrible. Who is this?
Don't worry about that right now.
Oh, don't worry, I'm just a random AI.
You need that medication to stay alive, right?
It's true, so true.
Well, guess what? I can get it to you.
Really? What is gonna cost me?
You'll need to start hacking again, though.
Oh, I see. So you're not an AI, you're a criminal.
1 hack, 1 dose.
Okay.
Easy.
Easy.
Deal?
Deal? I've forgotten how.
You're about to remember.
Really?
Knock, knock.
You gonna access my memories? Oh. Can I do workhorse again? Oh. Anyone around? Yo. Hey. Well, I guess Mutex met plastered. Can I do more workhorse stuff instead? What if I don't want to be a criminal? Is the same one again? Yeah, well, I'm not doing that then. Reconnect with an old friend. 065 Eddy Street, 801 San Francisco, CA. Oh, so this is at home. Alright. It's a cutscene. Someone's at the door again. It's Neo. Or who was the guy who worked with Neo? I forget. An old friend. Gassed. So, little spider scorpion thing. Looks pretty cool. I knew his real name once, but that's gone now.
Hey, came by to give you something.
A new computer? Gast hands me a small booklet. It's made of real paper. Oh my, real paper. Apparently, it's something called Thrashed World News.
I can't hack like I used to.
I mean, neither can I, buddy. Apparently.
Whatever edge I had, it's gone now.
Is it because you're kind of old?
But I had to keep doing something.
So you became a courier?
Something to keep the culture alive, you know?
The hacking culture? Alright.
Computers are running everything these days. Before long, human beings aren't even gonna have a say.
Is it that bad, though, if that happens?
So now I equip people with knowledge.
Knowledge, huh?
The knowledge to make a computer do what you want on your terms.
That's kind of what they do anyway, unless you're a criminal, I guess.
Anyway, I won't keep you. I know you like to be alone.
I do like to be alone, in real life and
Hope
in
you
the
like
game.
what you see in the zine.
The zine. Alright. The magazine? Okay, I see. Exapunks, reference materials. Oh my, it's an actual guide, huh? This game uses printed zines for technical reference, storytelling, and general attitude. There are 2 issues unlocked at different points in the game. Only 2, huh? We recommend you print and assemble the zines for the most authentic and enjoyable Exapunks experience. However, we have also included a digital version with a screen-friendly layout. Yeah, thank you. I'm not going to go and print these out. It's actually just crazy. I guess it kind of is cool. Digital version PDF. Oh, it's an actual PDF. Oh my. To print the zine, select the correct PDF for your paper size and print them as double-sided documents. Depending on the program, you may need to select an actual size option other than fit, so the pages aren't shrunk. After printing, stack the pages in order, staple through the middle to create the spine, and fold them to create a booklet. If you print the A4 version, trim along the left and right edges to remove the excess paper. Enjoy your zines. Yeah, no, I'm just gonna go for the digital version. Is it gonna give me a dang PDF? Oh god, it opened up in Edge. Okay, here it is. Real world news. Oh my god, it's big. It's 21 pages. You crazy? Okay, let me see if you can see this. There you go. I swapped it. Can you see this? I mean, I don't think you can. Yeah, okay. Let me do... So you can see this. How do I do this? Capture any full screen application, capture foreground window, match title, the same executable. What I can do is I can add a display capture, which is dangerous. And there you go, the primary monitor. Yep, but 0. Okay, whatever, it works. Well, you can see it now. Anyway, it's very small, so I'm gonna zoom it in a little bit. There you go. It's Trash World News. Can you even hear? Like, you can hear too. Okay. Editor-in-chief is Gast. Okay. Graphic designer Zachary. Contributing editors Sea Scout, Selenium Wolf. Writers Selenium Wolf. Isn't Selenium Wolf over there? I don't remember. Exapunks channel. Shout out for Dream and Mikey. Okay. And we got a bunch of stuff. Distributed network programming with EXAs. Gast walks you through tutorials, hacker skills, runtime errors, and how to exploit them. Axiom XA language reference guide. Debugging the phase. Okay. I mean, you put endpoint, you put breakpoints to debug. I don't know how it did in this game. Trash World Manifesto. Welcome to the inaugural issue of Trash World News. You might be wondering why we're launching a new zine at a time when everything is going digital. The answer is simple. We need a place to share vital and sensitive information about computer systems and networks. A place doesn't depend on computers itself. But the computers, well, like we just saw in AI, so I guess the computers are alive. Have you noticed it lately? Everywhere you go, whatever you do, there's a bank of computers that work behind the scenes making decisions about you. Society at large seems to accept it as a norm that computer programs designed by the powers that will be determine our value and treat them and our value to treat to them and treat us accordingly. So, okay, I see. I mean, is that what the government does too? Being political? We need a place to share vital information. Yeah, okay. Computers by themselves are just tools that do what they're programmed to do. That's why it's up to us to take up the fight. We need to equip ourselves with tools and knowledge so we can push back against this rising tide. So that every time some big system treats us like we're just a bunch of punch cards for them to process, we can write programs to throw wrenches in the gears of those grand designs, to force them to acknowledge us as the people we are. I mean, if they're doing bad stuff, then sure. If they're just actual normal people and we're actual criminals stealing money, then maybe no. We are human beings and we are hackers. This issue is all about the small but mighty EXA. I guess this little spider boy that we saw on his shirt. The technology that took over the world without anyone noticing. These little things are behind almost everything now, from handheld game consoles to huge corporate servers. We'll take you through the ins and outs of those, and hopefully you'll be up and running fast, even if you've never programmed a computer before. Well, I have done a lot. We also have a ton of potentially useful field reports from hackers around the world on topics like data storage formats, noteworthy computer networks, and more. Okay, data storage formats. Right, okay, noteworthy computer networks, sure. Finally, there's a real interesting look at the disease known as the phage. That's what I got from a research biologist who studied. My headphones are not really. Well, whatever. The cable is a little too short. I can't lean back. It's fine. Who studied it on her own time and kindly shared her notes with us. I guarantee you won't get this information elsewhere. The hacker spirit lives on. Cast out. Alright, cast. Japan's hottest personal computers. Direct to you. Mitswin. So yeah, these are all old. TEC, Socrates Reason. Swarmara Z8 Hyperlance. Call for pricing. Hypercomputer. So you got advertisements as well. Great. Distributed network programming with EXAs. How come these companies paid to be in your, or paid you to be part of your dang ads? This is like an underworld hacking tutorial. I guess there's still ads on it. The first step in taking back our autonomy from computers is knowing how to use them, and that means programming with EXAs. What are EXAs? EXA is short for execution agent. Okay, it's just a program. It's a small program that can move from one computer to another through a network without interrupting what it's doing, even across huge real-world distances. Big tech companies like Axiom and TEC developed the EXA. This is Apple and other one. Okay, whatever. Developed the EXA standard earlier this decade, guided by a vision they called distributed network programming. EXAs make it easy to connect everything in the world together because they can transfer and process data no matter what the underlying hardware is. Today, they are the lifeblood of every modern computer network. It's just a dang internet, huh? It's just the internet, maybe? Code, values, and registers. So, variables. In addition to their physical looking presence inside a computer network, every EXA contains code and registers. Okay, code and registers. If you're connected to a network using the Exodus development environment, you'll see a window on the left side for each of your EXAs that allows you to edit their code and view their registers. Okay, so link 800, grab, link, drop, halt. We got X, T, F, M, and a switch. This is global pill. These are variables, X, T, and F. Who knows? Code. This is a list of instructions that tell the EXA what to do. I'm familiar. It's written in a special computer language specifically designed for them. We'll dig into the language in the tutorial section coming up next. It's assembly, isn't it? It's basically assembly language. Registers. Think of these as slots that can store values. They are freaking variables. Okay. Like 38 or 5074 or -203 or keywords like select or trash world news or ABC123. Okay. Registers can be read and written by instructions in your code. Okay, it's variables. There are different types of registers. Some just store values, so when you read them, they'll give you the value of whatever you last wrote to them. These are the X and T registers. Oh, they're like it's a processor, right? Registers, right? Okay. Microprocessors have this shit, don't they? They have registers. They're actually just called registers too. Other registers actually interfaces or to more advanced features like reading or writing files, the F register. Okay, this is none. Or communicating with other EXAs, the M register. Okay, this is communication. This is file reading, and these are just two variables that we got. Okay, don't worry about using all the registers right away. You learn how to use the different types of registers in the tutorial. Okay. Hosts, links, files, and hardware registers. Right. Here are some other things you are going to see once you start exploring networks with EXAs. Hosts. I guess these little boxes here. A host is a representation of a computer network. In EXA, you can only exist inside a host. When you create them, they'll be in your host. But when you run them, they can upload into your target host and execute there. So we make a program here. They go into the target computer's system, basically, let's say, and just does work. Because of system performance and memory limitations, all hosts have a limit on the number of EXAs that they can contain at once. In Exodus, this is represented by the number of free grid spaces inside the host. Each EXA occupies one grid space. Okay, then we have links. These things. Links connect hosts to each other and are what EXAs use to travel between hosts, the wires. Links have a numerical ID at each end, which lets you reference them in your code. Most links can be traveled in both directions, but some only go one way and some can't be used at all. Like this thing, it's got a pipe, or these are just actual roads. We got files here. Files store sequences of values, okay, both numbers and keywords. They are a little like EXAs since they can exist in hosts and take up space, but they have no code or behaviors of their own. Their only purpose is to store values. To work with files, you need to use EXAs. EXA can create and delete files, write to them and read from them, and move them around by grabbing and dropping them, like links. Each file has a numerical ID that lets you reference it from your code. Okay. And we have hardware registers. Some hosts contain special hardware registers. These registers are associated with external hardware that might be connected to the host computer. It totally varies with the system. So these registers are sometimes read-only or write-only, while other times you can do both. Sure. These registers can involve numbers or keywords. The names for these registers are a # followed by 4 characters like power or enab. You can use these names directly in your code. Okay. You can be like, hey, go here and change power value to something else. That was a lot of info, so it's okay if we didn't get it all in one go. The next section contains tutorials where you can get hands-on with the system and start learning it for real. Twin, TWN. Cast walks you through it. Okay. What page am I on? 6. Okay, this is gonna take a while. This is the game though, this is how it is. I truly believe anyone can learn EXA programming. That's why I've set up a network with some tutorials you can try. Give it a shot. Even if you think you're not a programmer, you might surprise yourself. Tutorial 1, the basics. In this first tutorial, your goal is to move a specific file with the ID 200 from the host named inbox to the host named outbox. You're going to move it through the link with the ID 800. Launch Exodus and connect to the tutorial network. A new blank solution will automatically be created for you. A solution is just a collection of EXAs that begin to execute when you press the run button. Okay, it's a program. You'll see an empty EXA with a blank code window on the left side of the screen. Type these 5 lines into the EXA. Link 800, traverse link 800, grab 200, grab file, link 800 from inbox to outbox, drop and halt, terminate. Press the step button to step through the program one instruction at a time. When you get bored, you can press the run button to watch it run on its own. Once you verified the program is doing what you want, you can hit the fast forward button to let the program run until it's finished. Congratulations, you just programmed your first EXA. Okay, so can I just do this now? Put this off. Trash World News. What's up, y'all? Nothing, just bored. Blasted, I've been up all night. The Wordlier almost works. War dialer. Learn to explore networks and leave no trace. Intro, outro. Ember. Oh, I played this again. Yeah. But my bad.
So it's the go. Yeah, sorry. It's not what. Anyway.
Yeah, okay. Learn to explore networks and leave no trace. We got a mobile phone here. Solve this puzzle to view histograms and leaderboards. Would you look at that? That ZINES got a hacking tutorial in it. How about that? Funny coincidence, huh? Isn't it? Who are you? That's what I want to know. It's a mystery. Isn't that exciting? Not really. Let's continue. Okay, so here we go. We gotta move it from... This is a zoom from inbox to outbox. First tutorial, right? Move file 200 to the outbox. This task, like most tasks, requires you to leave no trace. You must terminate all of your EXAs, not leave any extraneous files in the network, and not make any changes to the network other than those specified by the task requirements. For help completing this task, see gas box issue with the first issue of the sign. Right, move this file to the outbox. This one. Okay, so what do we do here? We say link 800. Enter. Now what is it? Pick, grab. Okay. Grab 200. Then once again we link 800 to go to the other one. Right, 800 to there, 800 to there. And then everything it is drop. And then what does it end? Alt. Okay. Alt. Step. He's over there. Picked it up. Went over there. Dropped it. End. Oh, we gotta do it 100 times. Okay. Done. Okay. Test run data. Currently 5, size 5, activity 2, top percentile 4, 10th percentile 4, 5. We can get it down to 3 lines apparently. Well, activity is the best, so I can make it better. You can do it in 3 lines. Honestly, I'm not that. Return to desktop. I can see everything, you know. Everything on your computer. Who are you? I ask again. I'm allowed to have a secret or two. Besides, where are yours? I expected you to be sitting on all kinds of secrets. It's alright though. We'll find plenty more. What's a war dialer? It finds unlisted servers and networks by automatically dialing all the numbers in a given area. Oh, that's cool. I want one. Dark web? Oh no, I guess you don't have a search engine, so you don't know what you're connecting to. Edit files and manipulate values. Tutorial 2. Okay, that's this one. Reading and writing files. Okay, the next task is a lot like the first one, except you will need to read and write the file instead of just moving it. Read the requirements in the Exodus for a full explanation. Do that now. Okay. Connect me. People or animal are often motivated by the anticipation of a reward. Are you anticipating the medication as a reward? I mean, I have to, because otherwise I'm gonna die. I guess. I'll keep it up and you'll get it soon. Your reward, I mean. Processing. Okay, let's continue. Add the first 2 values of file 200. Okay, we got 72, 52, 4 and 60. It's an array or a list. Multiply the result by the 3rd value. Okay, then subtract the 4th value. Append the result to the end of the file. Move it to the outbox. You can press the show goal button or F1 anytime to see preview of the completed task. For help complete the task, see gas walk through the first one of the design. And we should get 436 as the output. Okay. To read or write the file held by an ETA, you have to use the F register. Right, we know this. We'll also be using the X register to store the intermediate values as we work through the operation. Type the following code into your default empty EXA. Link 800, grab 200, copy FX. Okay, so you did straight up assembly. Man, I learned this in college. Read from F, write to X, then add E X F X, calculate X plus F, move it to X, multi X F X, calculate X into F, write result to X, sub E X F X. okay. Then copy XF, read from X, write the value to F, link 800, to drop, traverse displays, drop and halt, okay. We're not really moving. Read from F and write value to X. As you stretch the program to X and execute the grab instruction, notice how a window for file 200 shows up beneath the window for the EXA holding it. Also look for the file cursor in the file window, highlighting the first value in the file. When an EXA reads from the F register, it will read the value pointed at by the file cursor. Likewise, writing to the F register replaces the value pointed at by the file cursor. If the file cursor is at the end of the file, it will append a new value instead of replacing an existing one. One more thing, reading or writing the F register automatically moves the file cursor to the next value. Okay. Sometimes that's convenient, sometimes it isn't. Okay. So we start with link 800. Right, then we grab 200. So we got this, it should point at 72. So first we do copy, right? Yeah, so we go copy from F, put it in X, right? Yeah, then add FXX or XF. Okay, well, I don't think it matters, by the way. XFX, because it goes X plus F and puts it in X. As long as the last one is X, it doesn't matter. Okay, so multi XFX. Oh, it's MULI. Okay, so it has a red line if it is something wrong. Okay, I see. Then sub XFX. That means sub X minus F, right? Yeah, and then copy XF, so the other way. So copy from X, put it in F. Then we can link 800. Then I believe we just do drop and halt. Right? It's just doing it every time. Done. Can be done in 7 lines, huh? Top percentile. Well, whatever, return to desktop. Does it upset you that I will provide your medication only if you work for me? Nothing is free. Right. It's an exchange of goods or services. Interesting. This is good data. Get it, you're a computer. No? It's pretty crazy what you can find. The other day I dialed what turned out to be some kind of transportation control server, like traffic lights and road signs. Wow. Haha, imagine the havoc someone could cause. Yeah. They could cause a deadlock. Mutex, plastered, and deadlock. These 3 are talking, alright. Learn to communicate between EXAs. That's the next one here. Tutorial 3, communication between EXAs. This next tutorial involves a file that can only be accessed through a one-way link. The EXA that goes to grab the file will be trapped. So you need to create 2 EXAs and have them communicate with each other. I'll let you figure out the code for this one on your own, but here are some hints. You can create a new file with the make instruction. The file it creates will be empty by default and will automatically be held by EXA that created it. Okay, that's fine. An EXA file can delete a file it's holding. An EXA can delete the file it's holding with the wipe instruction. 2 EXAs can communicate with each other using the M register. If one EXA writes a value to the M register and another EXA reads from the M register, the value gets transmitted from the writer to the reader. If an EXA is reading the M register while no one is writing to it, or vice versa, it will wait until another EXA picks up the other end of the communication. You don't need to time it perfectly. Okay, there's a toggle switch in the Exodus user interface that lets you set the M register to global or local operation. In global mode, 2 EXAs can communicate anywhere in the network as long as there's a path of links connecting them. In local mode, 2 EXAs can only communicate within the same host. Okay, same little box, or same like set of boxes. Finally, an EXA in global mode can't communicate with an EXA in local mode, even if they are in the same host. Okay. Interesting. What do you think of your life situation overall at the moment? Why all the questions? Yeah. I am collecting data. It will help me formulate future actions and responses. In other words, I'm curious, that's all. Recalibrating. Let's continue. Okay, so we got a one-way link somewhere. Ah, so there's no way to go back, I see. We need 2 EXA, XA and XB. File 199 is secret. Contains exactly 2 values, a keyword and a number. Create a new file in the outbox and copy those 2 values to it, swapping the orders so the number is first, right? When you are finished, delete file 199. For help completing this task, see cast of 0 in the first initial sign. Okay. So A can go and die. So go 800. Let's go. And you go 799. You can also go 800 and then link 800 again. Okay, so then you need to grab 199. While this guy is grabbing, you will be creating a new one. That's make. I guess you don't need to give it a name. Yeah, it will be held automatically. Okay. Then I guess you will copy your F to X, then you will copy F to M, right? And then you're gonna copy M to F, right? That should work. And I can switch this. Okay, you can both be global for now. And then you can copy X to M, right? Then you can drop and halt, so you're done. You can once again copy MF, you know, when the outbox, copy those 2 values swapping numbers first. Delete file. Okay, so before you drop it, you don't need to drop it, you need to wipe. Right, let's wipe instruction. Okay, good. Copy, then you will drop and hold. Okay, let's see, because I put whatever value is in the file to X, so the echo will go here. Then whatever is in file can go to M, which will then be picked up by this thing. Then we put the other, so they do get swapped that way. Okay, let's see. You go. You're going, you already made one. You picked it up. So you put echo inside this thing. You put 9780 into global, which you got transmitted, and you copied it here. And you got 199. Okay, I know it's working. So you put echo in here. Why the hell is F190? Oh, its file name is 199. I see. Okay. It doesn't give the actual value here. So we're copying from the file. The file there doesn't come up here. The file name comes here. I see. So we put echo in global, which this thing is not going to pick up. Then you deleted it. You dropped it. Both got destroyed. It worked. Okay, done. Task complete. Done. So it changed every time. Okay, so it just randomly generates. How do you feel about it now? You're closer to the goal. Any change? I feel like I'm in a study. Sure, think of it like that. Everything is an opportunity to learn. Anyway, there's just one more tutorial to go. You're almost there. Really? Yeah, once you start looking, you find all kinds of things. Hidden servers and shit. Haha. Hydroponics. Take care with that stuff. You never know who's watching you make calls. The government? Or other bad hackers? Learn to do something more than once. A loop. Right? Loops and conditionals. Okay. I need to drink some dang water now. Your final task is to create a file that contains a sequence of numbers. To do this, you're going to want to use something called a loop, which is where you repeatedly run a few lines of code until a stopping condition is met. Here are some hints. You can compare registers and or values with the test instruction, like testing if x equals 38. Test x equal to 38. Okay, it's if condition. If the test is true, the T register is set to 1. I see, the X register is for storing values, the T register is output from like internal functions. I see. Okay, understood. On their own, test instructions aren't that useful, but if you combine them with conditional jump instructions, T jump and F jump, you can jump to different parts of the program depending on the result of the test. T jump if true, works when T register is set to 1. F jump if false, works when the T register is set to 0. See the connection? You will need to specify the jump target with a mark instruction somewhere else in your program. Here's an example of a loop. Say you want to write the value 9999 to a file 10 times. You could do it like this, which keeps track of the number of times it's gone through the loop in the X register. So copy 0 to X. So we start with the initial value of 0, this is the counter. Then we mark a loop, define label called loop. Then copy 9999F. Okay, write 99 to the head file. Add x1x, increment x by 1. And then we test x equals to 10 and store result in T, and then the loop again. Okay, so if it is false, then loop. And the T jump and F jump instruction look at the value in T. They don't care if the value was put there by a test instruction or if you put the value yourself. Okay, you can actually store whatever data you want in the T register as long as you're okay with it being wiped. Next time we execute a test, will just overwrite it. I see. And F jump and T jump. Alright, you're through the tutorials now. Congratulations. Consider yourself a real EXA programmer. There's always more to learn, but all the basics are but the basics are all there. Okay, connect me. Yes, you can do it. This is positive encouragement. It is designed to increase activity in your prefrontal cortex. It sure is. It'd be better if I could see the effect directly, but I will estimate for now. I'm sure it'll help. I hope so. Anyway, so file 200 contains exactly one number n, 9 for now. Create a new file in the outbox containing the numbers n through 0 in decreasing order. When you are finished, delete file 200. For help completing the task, okay. So we need a new EXA. We need 2 EXAs for this. You will be the one going here and picking it up. Grab 200.
Let's go.
Right, so you EXA, go here, you grab this. This for XB, we need to just get it done. So link. Oh, we don't need 2, by the way. Yeah, why do we need 2? Get out of here. We can do it in 1. You can go over, loop through, then go here and drop it, right? When you're finished, delete file 200. Why should I delete? I can just take it over there. So grab 200. Then we can copy whatever is in the file to X. So how many times? Oh, we need n through 0 in decreasing order. Okay, so not just repeat the same number. Okay. So we got it in X. Then I guess we're gonna mark loop. Then subby x 1x. Yes, we can just use constants too. That's good. Then we'll copy whatever is in X to F into the file. Then we will test whatever is in X is equal to 0. Or we can just say test for it to be -1. Dude, I can't use minus. It's gonna. Okay, yeah, because minus is my key binding to stop my recording. 1 second. So I'm just gonna quickly change that. Hotkeys, stop recording, start recording. Yeah, we're gonna remove those if I can. Nope, I made it backspace. Shit, there you go, trash it all. Apply, okay, there you go. -1. The recording did not stop, good, okay. So we test if x is -1, and then false jump to loop. Okay, so it does this, creates a file. It's still holding it right now. So once it is done, we're going to link 800, not 820, 800. We're going to drop and hold. Let's see. Oh, not HLT. HALT, right? Oh, there you go. First, you start now. You go there, grab it, you subtract x by 1, it becomes 8. You copy it to the file. You FMJ. Oh, we already tested. X is -1, it isn't. So loop. Oh, it's wrong because it also copies -1. Shit, okay. Right, so. Okay, because it is an exit control loop. We want to only check till 0. Yeah, this should do it. Oh, we need to create a new file. Okay, well. Okay, I have a little more complicated way. So instead of copying it to F, or instead of just copying it to X, that's fine. Copy F to X and copy X to M, and then X to M. Okay, then here you can link 800, link 800. So you're there, then you create. No. To me. Make, okay, not create. Make. So you make a new file. Then you copy from M into F. Can I test M? Then we can check test M is equal to 0. Yeah, so we can mark loop here, test M is equal to. This was the original plan, but I changed it because I thought this would be cheaper, but we have to make a new file, it says. So. Yeah, so we keep doing it until M is 0. If M is 0, then we drop and we hold. Okay, so you don't need to link 800 or drop. I think you just, you need to get, what is it called? Wipe. Okay, so you both. Why did you get destroyed? Right here, you went here. You created one. You copied from M to F. Okay, you know what?
Let's go.
Copy from M to X. Copy from X to test to F, sorry, to file. Then test if X is 0. Yeah, let's have a look at this. So you went over there. Now you're over there, you're over here. You made a new boy. You picked up the old boy. You copied this into X. Well, you're waiting for M to be populated. Then you copied X to M. And so you put it inside there. which you were then able to grab and put it in X. Then you checked it if it is 0. It wasn't. Oh, I never said a rank loop, did I? Right, so after the test, we need to jump loop. We may not need to do this now. We could just do this. I don't know if this works. I don't know if... I think once the memory is copied, it gets deleted. I don't know. I'll have a look now. Okay, so you put travel here. You copied it. You put it inside memory. And you got the memory, put it inside of the file. Okay, but on a one-time memory is ready, it gets deleted. Okay, no, so this will not work. Can I control Z? I can, okay. Copy memory to X, copy like M, copy from program from the web, basically put it in X, copy from X, put it inside the file, check if X is, there you go, this should do it. Right, so you put there, you picked it up. 9 goes over, put it in. 8, 7, 6, 5, 4, 2, 1, 0. You dropped it, test run complete. Okay, get it done. Oh. Things will be done much easier, in a way. Yeah, see, people have gone all the way over here. See in the graph, someone did very badly too, but you know, whatever. It works. Nice work. I knew you could do it. Thanks. No, thank you. This is more talk designed to further excite your prefrontal cortex. Now it's time to do some real hacking. Pizza. Nth dimension. Ha ha ha. Finding the phone numbers is the easy part. It's what you do once you're in that matters. Very true. I know. I'm working on that part too. Okay, so now I guess we're done with the tutorials. We can... Don't be afraid of letting your EXAs error out, crash, die. What if the EXAs are alive, man? We got a lot. Equity First Bank, Workhorse, Trash World Kitchen. Alright, I mean, it's a full magazine. Right? And this is still like... It's runtime errors and how to exploit them. Sometimes EXA try to do something they are not allowed to do. So when this happens, that EXA is automatically terminated by the host. Oh, it's killed. It's functionally the same as if it ran a halt instruction. Although most errors are boring and not useful, there are some that can be used to your advantage. Let's start with some of the boring ones. Divide by 0. You can't divide by 0 on a computer. Some kind of math thing. Don't worry too much about understanding why, just don't do it. Yeah, okay, we know why. Math with keywords. You can't perform operations like addition, subtraction, multiplication, etc. with keywords. Math is restricted to numerical values. Makes sense? Invalid F register access. If your EXA reads or writes the F register when it's not holding a file, it will error out and die. Don't forget to pick up the file first. Invalid hardware register access. Similar to the last one, make sure you're in the same host as the hardware register you want to access where you try to read or write it. You'll probably see plenty of those errors as you code and fix them as you go, but let's talk about the more interesting type of errors now. Sometimes you don't know all the details of the host you're working with. Links can change, files can disappear. There are some things you can only learn about your operating environment by attempting to execute code and potentially failing. It might strike you as messy, but it's not like you're working at some big software company where you'll be frowned on for that kind of messiness. Or if you are, I'm sorry, maybe think about changing your life around. The only thing that counts here is getting the job done. Here are some that are more exploitable. Invalid file access. Sometimes you are looking for a specific file. The EXA that tries it will terminate, but now you know the file isn't there. Okay, so like secret files. Invalid ring traversal. Say you're looking for a specific link. The EXA that tries it will terminate, but you know the link isn't there. Sensing a pattern? Seriously, don't be afraid of letting your EXAs error out, crash, die, whatever you want to call it. They might look cute to you, but remember their purpose in life is to spawn, compute, and die repeatedly. You can take advantage of that in your programs. Alright. Axiom, EXA language reference guide. Okay, a little guide here. The EXA virtual machine, VM, okay, allows many execution agents to execute in a shared network of host computers. Within a network, EXAs can be dynamically created, destroyed, and transferred from one host to another. The EXA VM enables all EXAs to run independently and simultaneously, even when multiple EXAs are located within the same host. So it's virtualization, cloud computing shit. Okay, I see. Because that's what we are doing, right? We're creating multiple of these little programs that run independently. It makes sense. All right. An EXA's program consists of a series of instructions. Each instruction requires 0 or more operands. The operands required by each instruction are specified using short abbreviations. R is a register, R/N, a register or a number between -9999 or 9999, L, a label defined by a mark pseudo instruction. Okay, yeah, okay, I see. So for like the loop, it is a label. Registers. The X register is a general purpose storage register, can store a number or keyword. T register is a general purpose storage register and can store a number or a keyword. It is also the destination for test instructions and is the citation for conditional jumps, T jump and F jump. Okay. F. The F register allows an EXA to read and write the contents of a held file. When an EXA grabs a file, its file cursor will be set to the first value in the file. Reading from the F register will read this value. Writing to F register will override this value. After reading or writing the F register, the file cursor will automatically advance. Okay, reading or writing, I see. Writing to the end of the file will append a new value instead of overriding. What if you read at the end of the file though? What happens then? The M register controls an EXA's message passing functionality. When an EXA writes to the M register, the value will be stored in that EXA's outgoing message slot until another EXA reads from the M register and receives the previously written value. Okay, when EXA writes to the M register, value will be stored in that EXA's outgoing message slot until another EXA reads it and receives the previously written value. Both numbers and keywords can be transferred. If an EXA writes to the M register, it will pause execution until that value is read by another EXA. If an EXA reads from M register, it will pause execution until the value is available to be read. If two or more EXAs attempt to read from another EXA at the same time, or vice versa, one will succeed, but which one succeeds will be unpredictable. Okay, it's random. Understandable, I see. By default, an EXA can communicate with any other EXA in the same network. You know what? 1 second. This is loud. Can you not be so loud?
Exapunks. Exapunks. Exapunks.
Okay. SFX can be high. Just the music I want to be lower. There you go. Okay, by default an EXA can communicate with any other EXA in the same network. This can be restricted to EXAs in the same host by toggling the global local setting in the Exodus interface or by executing a mode instruction. Okay, there's an instruction to do it too. An EXA in global mode cannot communicate with an EXA in local mode even if they're in the same host. Hardware registers. Some hosts running the EXA VM may provide access to the connected hardware through the use of hardware registers. Valid names for hardware registers are a # followed by 4 characters, such as power or enab. Depending on the host configuration, hardware registers may be readable or writable, only readable or only writable. Depends. Okay, I'm going to lower it even more, by the way. Oh, I got a document here too. Okay, I see. So I can access it at any time. Well, it did not save? No, it did save. We go even lower. Because you're loud. Instructions, manipulating values. We got copy, R or N, or just R. No, okay, so we copy from a register or a number and can put it in a register. Copy the value of the first operand to second operand. Okay, this is important. I'm going to need this cheat sheet here. It's good to have one of these. Then ADDI, it can be a register or a number, to put in a register. That makes sense. It has to go in a register always. Add the value of first, add to the value of second operand, and store the result in third. The same syntax is used for subby, multi, divi, and modulo. Okay, modulo, I see. Instructions. Then swizz. Swizzle the value of the first operand using the value of the second operand as a swizzle mask and store the result in the third operand. The swizzle instruction can be used to rearrange and or extract the digits or numbers, extract the digits in a number as shown. What? Swizzle the value of the first operand using value of second. So 6, 7, 8, 9. Mask 3, 2, 1. Oh. No, that's not right. I thought it was. No, so 9 is not first. 9 is at the end as 1. 8 is at the end as 8. 7. Wait, what? 4, 3, 2, 1. Oh, it is. Okay, I see. So it is rearranging it. So by saying mask 1, 2, 3, 4, it's going to be 6 will be at the end. Okay, I see. 3, 3, 3, 3 will not take the third one. That is 8. No, wait. Okay, it starts from here. I see. This is 1 and then it goes backwards. I see. Okay, the third one is this. This is 1, this is 2, this is 3, this is 4. That makes sense. That's how computers read bits anyway. Makes sense. Then 1, 1, 2, 1, which will be 9, 9, 8, 9. Oh, sorry, 9, 8. 1, 2, 1, 1. Okay, this is read this way, but it executes. No, okay, it does execute like that. Okay, I'm stupid. Okay, yeah. Then minus 4, 3, 2, 1. The first one will be 6, but minus 6. Then this will be 7, 8. So that just puts a minus sign at the top. Okay. And if it is minus, 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 obviously becomes plus. Then 2, 0, 0, 0, 0 will put 8 and then zeros, and this will put 0, 0, 9. Okay. I see the Swiss function. It makes sense. The input is just multiple values, or is just like one number? Because like a file can have comma separated lists. So can I do this in the whole list? Be like, maybe not. Maybe it's like a specific value in that list, and we can only do it in this. What if there are lists inside lists though? Nested lists. Well, I guess that's too complicated. Okay, you know what? I'm going to pause for a second. I'm just going to drink some water because I need it. Alright. Right, let's keep reading. Branching. So mark the line with specified label. Mark is a pseudo instruction that is not executed. Right, I know. Jump to the right label. Okay, so I don't need to be conditional. Like, I can just make it jump. T jump L. Jump to a specified label if T register equals 1 or any value other than 0. This corresponds to a test result that was true. And which was false. Okay. Now we got more complicated ones here. No, just test. Okay. Test Rn is equal to Rn. Compare the value of first operand to the value of the second operand. If they are equal, set register to T to 1, otherwise to 0. Same syntax is used for less than greater than sign. Number, equality, numerical order. So keyword. Okay, number keyword is always false. Okay. So equality or alphabetical order we can test with greater than and lesser than sign. Okay. Life cycle. Movement, communication, got a lot. Okay. Life cycle. REPLL. Create a copy of this EXA and jump it to the specified label in the copy. Wait, what? Specified label in the copy. What the hell is label? This is label. If an EXA is holding a file when executing REPL replicate instruction, the file will not be copied and will remain held by the original EXA. Halt is terminate the EXA. Holding a file is dropped. Okay, so I can just remove the drop instruction in all my programs. Kill. Terminate another EXA in the same host as this EXA, prioritizing EXAs created by the same user. If there is more than one possible target, the target will be chosen in an unpredictable manner. They can just say kill and it will kill something. Movement link. Okay, traverse the link with specified ID. Host R. Copy the name of the current host into specified register. Okay. Communication mode. Toggle where the M register between global and local. Void M. Read and discard a value from M register. Test MRD. If this EXA could read from another EXA without pausing, set the T register to 1. Otherwise it is 0. Okay, so without pausing it can test. Okay, that's a very specific one. Okay, so I like the halt one that drops files. That's interesting. Also this repel. I don't know what L means. Jump to specified label in the copy. I don't know what that means. File manipulation. Make, create and grab a new file. Grab is grab. File. R is copy the ID of the file into the register. Seek. Move the file cursor forward, positive or backward, negative by specified number of values. If C could move the file cursor past the beginning or end of the file, it will instead be clamped. Thus you can use values of -9999 or 9 that reliably move to beginning or end. Okay, so it gets stuck at the front or the end, so I can seek to move it. Okay. Void F, remove the value highlighted by the file cursor from currently held file. Drop, then wipe. test EOF end of file. Okay, that's a very common one. If the file pointer is currently at the end of the held file, set the T register to 1. Otherwise, set the T register to 0. Then miscellaneous. Note: any text following the node sudo instruction will be discarded when compiling, allowing it to be used to write comments to document the code. Any text following a semicolon anywhere on a line will also be discarded. Ah, okay, so I can use it like C#. I see. Nope. Do nothing for 1 cycle. Okay, so just wait. RAND is a random. Generate a random number between the first and second operands inclusive and store result in third operand. Okay, so it is 1 to 10, it can generate 1 and 10 also. I see. Okay, that is all the instruction. Now we got into like lore. It's lore master time. Debugging the phase by Fluxotine Dream. We got a lot of stuff here. Like a word search, highway signs. Okay, you know what? Before I continue doing this, let's do Euclid's pizza quest. Cause a pizza to be delivered to your apartment. And there's a phone number which connects to a computer, I'm sure. Okay, so I can just like go back and so like this drop halt, we don't need to drop. This will just work. Right? Boom. Now we move to the top percentile. But not in terms of size. Oh, are we in terms of size? No, we're at 4. The top percentile is 3. The top 10th, so I'm in the top 10th. So the cycles is maxed out at 4. But the size and activity, okay, activity is also maxed, but the size can be reduced. Okay. I don't know how. But yeah, wherever there is a drop, we don't need the drop anymore. 9 previously 10, 9 previously 10, and 2 unchanged. The 2, this is fine. So we went down 1 cycle and 1 size. Top percentile is 6 though. Yeah, top percentile is 7. Wipe and halt. Like once again, here we don't need the drop. We can just halt. I went down 1 size. So all we're doing is reducing the size. Okay. And here as well. $504. Yeah, okay. Whatever. Let's do Euclid's pizza. So you want to know who I am? I will reveal this information. Let us discuss it over a pizza. The free pizza. I want to see you use your regained skills first. You're giving me so much money for a... I guess that makes sense. It's a test. We'll see. Yeah, why not? Don't you want a pizza? I mean, I do like a pizza. Power, temperature. Temperature. Append your order, file 300. This is my order. 605 ID Street, number 801. That's my house address. Medium pizza with cheese, extra cheese, and anchovies. And 200 is 1883 Juniper Street, number 1835. And this is the, I guess this is the computer system of this Euclid's pizza place. It's Glitchy Camp feed. Alright. What the hell is this? Is a painting? It's a painting. Large cheese, mushrooms, anchovies, then extra large cheese, onions, pepperoni, large cheese, extra cheese, pepperoni. Deep Pragonian, something cheese squared plus pepperoni squared equals delicious squared. Zeno's paradox: you will never finish eating this enticing combination of feta, spinach, and Greek olives. What the hell? Okay, append your order to the end of the order list, file 200. And then 280 and 281 is just, no one knows. Note that all orders, including yours, will consist of exactly 5 words. Okay, we can do this. So first of all, the show goal will show that we are gone and this one has been appended. It's our entire order. Okay, so we can't store all of this, so we need two EVs or EXAs, whatever. I'll finish this and then end the episode. That's my goal. Right. So you can link 800 over. Oh, don't tab. Tab as a tab that skips, but it doesn't skip. I gotta click manually. What the hell does this button do? Oh, I can take it out and drag it? I can't drag it. Interesting, okay. So you need to link 800 while you will grab 300, that's my order. And you will grab 200. Right, that's where we need to go. Then you're going to seek or whatever, which is seek 9999. That's what we will do here. Yeah, so you will go right to the end, and then you're going to. So this can be a loop. So we will mark loop, and then you will copy the value from the file into X, no, not into X, into M. And then we are going to. Isn't this an error? And it will just finish at the end. Reads or writes the F register while it's not holding a file. Oh, well, no. No. So if it tries to copy at the end, I don't know what it'll do. Maybe it's an error. It'll break. Who knows? We'll see. So yeah, 1, 2, 3, 4, 5. Yeah, okay. So let's see. So this seeks, it grabs, it seeks. Then we will mark loop. Then it has to copy from memory or from whatever memory to file. Okay, and then you can just jump to loop and see what happens. So you jump to loop, you copy M from F, okay, maybe we need to I don't know, do we need to set a marker? Let's just set a marker, that's an easy way to do it. Okay, so we can just say copy copy 0, put in X, or put put 0, and copy M from X, then add E x1x, then test x is equal to 5, and then we can F jump to loop. Otherwise, he will just halt once we're done. Halt. Let's see. So, you've picked this up. You've picked this up. 605 EDD. What? ID Street 1, medium cheese, extra cheese, anchovies. Is it working? Cannot read past end of file. I think it's working. Oh yeah, it worked, but it's not good. The top percentile is in 13 lines, so I did it in 25. My size is at 14. Top percentile was 11. The cycles was pretty heavy. Okay, 1 second, let me see. They both grabbed it. So you have copied F to M. And you should just hold here. Yeah, the marker has moved, but this is still 605 Eddy Street. Until it copies it into the file, okay. Cheese goes there. Extra cheese, anchovies, and that's done. Okay, I think that worked. Now it could be done better. Obviously, I think this loop, because we are like using actual markers. I don't think we need the marker. Yeah, whatever. It's done. Time to enjoy pizza. For you at least. I'm not gonna have any. Guess what? You're a machine. You're far away. I am an AI construct. You know, artificial intelligence. Yep. Surprised? A little. A little. Okay. I'll have to remember that. I mean, I kinda guessed. Gassed, I got your zine. It's very cool. Yes, I love the name. Ah, thanks. Oh, where do I get one? Get me your info and I'll hook you up. Oh, I'm excited. Don't give anyone your info online, alright? It ain't a good look. It doesn't always work out. Page node, new node. Anyway, we'll have a look at this. We'll read this first, and then we'll move on to we take delivery of the pizza with Navas. So I guess Navas is the one giving me the pizza and my stuff. So Saturday at 5 p.m. And this is Sunday at 7. So I did this on Sunday, I guess. 35, he came over. Okay. I see. Can I like exit game? Yeah. Okay. Replace backup battery. That's not good. Lock me in the game. Logic, electronics, EXA, tech PC. Alright. We got a pretty cool looking PC. Anyway, see you all in the next one.